I was expecting something a bit more detailed than this. You might want to think about how that sounds to others. I'm not convinced this really addresses the problem.
That may work in theory, but I'm not sure about practice. I'm a little surprised you didn't mention the limitations.
So you're saying there's no room for adjustment at all? Hey, did you have a chance to look at the draft I sent you last night?
Yeah. I skimmed through it this morning.
Just skimmed? I was kind of hoping for more detailed feedback.
Well, it's definitely a solid start. I just think it might benefit from another round of revisions.
Another round? I thought it was almost ready to submit.
I mean, structurally it's fine. Some of the arguments could be tightened up a bit.
So you're saying it's not ready yet?
I wouldn't put it that way. Let's just say the professor might ask some follow-up questions.
So, are you coming to the study group tonight?
Well, I was planning to, but today's been a bit longer than expected.
Oh, okay. We were hoping to finalize everything.
I figured. I just don't think I'd be very productive at this point.
That bad, huh?
Let's just say my brain stopped cooperating about an hour ago.
Got it. I guess we'll fill you in tomorrow.
That would probably be for the best.
Hey, did you finish the slides for tomorrow's presentation?
Well, they're mostly done.
Mostly. We're presenting first thing in the morning.
Right, which is why I stopped tweaking them at midnight.
So they're finalized?
If you consider finalized meaning nothing else could be improved, then no.
Should I be worried?
Only if you were expecting perfection.
Good afternoon, everyone. Before we begin today's lecture, I'd like to let you know that next week's session will still take place at the usual time, but not in this room. Due to ongoing maintenance in this building, the class has been relocated to Science Hall, room 204. Seating there is somewhat limited, so arriving a few minutes early would be a good idea, especially if you prefer to sit near the front.
Hello, this is a reminder for students enrolled in the Internship Preparation Workshop. While attendance today is optional, those who plan to apply for summer placements should strongly consider staying until the end. The final segment will cover common interview mistakes that past applicants have said they wished they'd known about earlier.
Good morning. I'd like to briefly address the upcoming deadline for submitting research proposals. Although the official due date is Friday at noon, students who anticipate needing feedback are encouraged to submit their drafts at least 2 days earlier. Experience has shown that last-minute submissions rarely allow enough time for meaningful revisions.
When astronomers discuss the possibility of life beyond Earth, attention often turns to exoplanets, located within what is commonly called the habitable zone. This zone refers to the range of distances from a star where liquid water could exist on a planet's surface. While this concept is useful, it can also be misleading if taken too literally. For example, several planets have been identified within their star's habitable zones, yet their actual conditions may be far from hospitable. Some of these planets are tidally locked, meaning one side permanently faces the star while the other remains in darkness. As a result, temperatures may be extreme, with scorching heat on one side and freezing cold on the other. Simply being in the right orbital zone does not guarantee a stable or life-supporting environment. Atmospheric composition adds another layer of complexity. A thick atmosphere can trap heat through a greenhouse effect, potentially making a planet too hot, even if it lies within the habitable zone. Conversely, a thin or non-existent atmosphere may allow heat to escape, preventing liquid water from forming at all. These factors suggest that habitability cannot be reduced to a single measurement. Instead, astronomers evaluate a combination of characteristics, including planetary mass, atmospheric chemistry, and stellar activity. The habitable zone remains a helpful starting point, but it is best understood as a guide rather than a definitive indicator of life-friendly conditions.
When people hear the word adaptation, they often assume it refers to a trait that makes an organism strictly better off. In evolutionary biology, however, adaptations rarely provide benefits without costs. Instead, many traits represent trade-offs shaped by environmental pressures over time. Consider the example of brightly colored skin in certain amphibians. These colors can serve as warning signals to predators, indicating that the animal is toxic or unpleasant to eat. From one perspective, this appears to be a clear advantage. However, producing chemical toxins requires energy, and bright coloration can also make an organism more visible to predators that are immune to those toxins. In other words, what protects the organism in one context may increase risk in another. Similar trade-offs appear in plants. Some species invest heavily in rapid growth to outcompete neighboring plants for sunlight. While this strategy can be effective in resource-rich environments, it often leaves the plant more vulnerable to drought or poor soil conditions. Slower-growing plants, by contrast, may survive longer under stress, but lose out when competition is intense. These examples highlight an important point. Evolution does not aim for perfection. Natural selection favors traits that are sufficient for survival and reproduction in a given environment, not traits that maximize every possible advantage. As conditions change, the balance of these trade-offs may shift, explaining why adaptations that once seemed beneficial can later become liabilities.
When people make decisions, they often believe they are acting rationally, carefully weighing all available information. However, research in psychology suggests that this assumption is not always accurate. One reason is the presence of cognitive biases, systematic patterns of thinking that influence judgment without conscious awareness. Take confirmation bias as an example. People tend to seek out information that supports what they already believe, while ignoring or dismissing evidence that challenges those beliefs. This bias can affect decisions in everyday life, such as choosing news sources, as well as more serious contexts like medical or financial choices. Another common bias is known as the anchoring effect. When individuals are exposed to an initial number or idea, even if it is arbitrary, it often influences subsequent judgments. For instance, in negotiations, the first price mentioned can shape how reasonable later offers seem, regardless of their objective value. What is important to note is that these biases do not necessarily indicate poor intelligence. In fact, they often arise because the brain is trying to process information efficiently. In situations involving uncertainty or limited time, relying on mental shortcuts can be useful. However, these shortcuts may also lead to predictable errors. Understanding cognitive biases does not eliminate them entirely, but it can encourage people to slow down, question their assumptions, and make more deliberate choices when accuracy truly matters.